Alright, so we have model 17, the product rule. So if we have two functions which are being multiplied in such a manner that they cannot be converted into a single function, then in order to differentiate, we will apply the product rule. The first step would be to consider one of the functions as u. I'll consider this whole function as u and this whole function as v. So in my case, I have cx plus d is v and ax plus b is u. U prime, that is the differential of u, is going to be a. Similarly, the differential of v is going to be v prime, that is the differential of this thing, which is c, simply c. Thus, this is the formula for the product rule. Whenever we'll apply the product rule, this is the formula we'll apply, and we simply have to substitute these values now. So if we were to simplify this, in this case, we'd end up with something like ax plus b plus substitute v, cx plus d, and substitute u prime. But you won't have to simplify expressions like this, but you get the point. Identify u and v, find u prime and v prime, and then finally apply the formula. Let's take our first example. In this case, I'll assume x square as u and this thing as v. So my u is x square. My u prime, that is the differential of u, would be 2x. Similarly, my v is square root of x plus 1, which can be written as x plus 1 in brackets and the bracket to the power half. The differential of v would be bring the power down, reduce the power by 1, and into differential of the bracket. Simplifying this would lead us to this expression. Finally, remember the formula for product rule. Write this down for reference and simply substitute the value. In this case, u is x squared. V prime is half square root of x plus 1 plus v, that is x plus 1 to the power half into 2x. If I simplify this, I'd end up with something like, let's write this down as square root first of all, and simplifying this expression would lead me to this expression right here. The denominator is same as this string. Thus, how about we express our final answer as a single fraction? No, the denominator is similar but not exactly the same, mind you. So this is the denominator. And this is written down as a single fraction. Further simplifying this, I'd end up with 5x squared plus 4x. And 2 square root of x plus 1. This is my final answer. Oops. Now you may be given or use a value of x to find the exact gradient, but this is the expression of the gradient. That is the differential of y. Moving on, again we have noticed that we have two expressions being multiplied and they cannot be expressed conveniently as a single expression. So 4x squared is u and our v is 3x minus I to the whole power 5. 3x minus 7 to the whole power 5. Mind you. So u is 4x squared. U prime is gonna be 8x. Similarly, v is 3x minus 7 and to the whole power 5. v prime is gonna be, bring the power down, reduce the power by 1 into differential of the bracket 3. And the final expression for v prime is 15 3x minus 7 to the whole power 4. Now we know the formula for product rule. Simply substitute the values as they are. So u is 4x squared, v prime is 15, 3x minus 7 to the whole power 4, 15 is out of the brackets mind you, plus v 3x minus 7 power 5, u prime 8x. Simplifying this expression, it's, a, it's gonna be a little long. You can keep simplifying with me. And this is what I have after one more step. I'll take this thing common. So 4 is the smaller power, so I have 3x minus 7 to the power 4 out of the brackets taken as common, and 60x squared left as it is, and 8x into 3x minus 7. Since I took this expression to the power 4 common. Further simplifying this would eventually lead me to, just a second, 60x squared plus 24x squared, which is equal to 84x squared minus 56x. And this is my final answer. Again, since we have our differential using the product rule, we can use any value of x to find the value of the gradient at that respective point. Otherwise, the examiner may also give us a value of x, which we will have to substitute and find the value of the gradient at that particular point. So this is where we wrap up product rule.